All right, eighth grade. Welcome back into section 3 now. Got the theme music going full throttle, so we're pretty excited about that as my swag factor continues to rise. So in section 3, we're going to be talking about slope-intercept form. This is the form that we graph equations in, and it's the most standardly used, the most standard form for writing linear equations. Remember, a linear equation is one that is, the graph is a line, hence the name linear, and that all of the exponents for y and x are 1. So it's just a y, just an x. There's no x squareds, x cubes, square roots, anything like that. All right, so let's take a look at this. Slope-intercept form always looks like y equals mx plus b. All right, our m stands for something, our b stands for something. This should not be anything new, that m stands for our slope. Okay, we've talked about that for the last couple sections, last couple years. We know that m stands for slope. The b, as you can guess by the name, stands for the y-intercept. Okay, if you don't remember what an intercept is where the graph crosses the axis. So if I have this xy axis and I have a graph that looks like this, there's my line, the y-intercept is, let's find the color you can see, is right there where the graph crosses the y-axis. Okay, that's what a y-intercept is. All right. The x-intercept is where it crosses the x-axis, so that would be over here for the x-intercept. But we don't need that for graphing right now. All right, we're just going to use the y-intercept. So first example, write an equation of the line whose slope is 3 and y-intercept is 5. So if I know that my slope is 3 and my y-intercept, which we call b, is 5, I can write the equation. Remember, our equation looks like this. And we're going to spend a lot of time doing this throughout sections 3, 4, and 5 is writing equations. What you always need to end up finding is a slope and a y-intercept. In this case, it's given to us, so it's pretty simple, pretty straightforward. Y equals 3x plus 5. I just took my b, plugged it in for m, or m plugged it in for m, and my b and plugged it in for b. Okay? That's example 1. That's the first thing we're going to be doing with it. The second thing we're going to be doing is graphing equations in slope-intercept form. So I'm given y equals 2/3 x plus 1. Let's go ahead and graph this. Negative 2/3 x plus 1. So we start with our xy coordinates. Okay? Then it says the first thing I do is graph the y-intercept. So let's take a look here. First thing is graphing the y-intercept, so I know I'm at plus 1. And I put a dot. Remember, the y-intercept is the one that goes up and down. Okay? Step 2 is to use my slope to find the second point. Remember, slope can be written as rise over run. And so I have negative 2 over 3. That tells me that the rise is negative 2, which means I'm going to go down 2. And the run is a positive 3. So I go to the right 3. And then I end up with a line that looks like this. Okay? That is all graphing is. Plot your y-intercept, then use the slope from that y-intercept to go up, down, left, and right. Let's try another one. 5x minus 3y equals 6. Okay? Before we start into this, we have to get it into y-intercept form, slope-intercept form. Okay? Notice the 5x and the 3y are on the same side, so we have to solve this first. 5x minus 3y equals 6. This is why we had to take time in the last section to learn how to solve for a variable, because we want to solve for y. Okay? That means I start by subtracting 5x. So I have negative 3y equals negative 5x plus 6. Then divide by negative 3. divide everything by -3, remember. And so y is equal to our slope, a negative and a negative become positive, so it becomes 5/3 x. And positive 6 divided by -3 becomes positive 3. So this is the line that we're going to graph, 5/3 x plus 3. So let's graph it. Remember, I start with my y-intercept. So start by going up 3. Then I use my slope at 5/3 to go up 5, 1, 2, 3, 4, 5, and over 3. That puts my dot right about there and my line there. All right? That's graphing slope-intercept form. On the back, our last example here, we have a little bit of a word problem. This shows you how linear equations can be used to solve actual problems and how it's used outside of just math class. Okay? It says the ideal heart rate for a 25-year-old who is exercising to burn fat is 117 beats per minute. For every year older than 25, that ideal heart rate drops 3 beats per minute. Okay? First thing it wants me to do is write a linear equation to find the ideal maximum heart rate for anyone over 25 who is exercising to burn fat. So I'm taking this information and I want to put it into a slope-intercept form. Okay? First thing we need to do is identify our variables, x and y. Okay? We can say that x stands for the number of years over 25 that somebody is. And y is the heart rate. Okay? Now, if we think about this for a minute, remember our slope-intercept form looks like this. Y equals mx plus b. Okay, what we really need to find are m and b. Remember, we're not plugging in numbers for x and y, we're plugging in numbers for m and b. So now that we've defined what x and y are, let's find m. Remember that m, our slope, stands for delta y over delta x. Since y is our heart rate, how is it changing? Let's take a look at the information up here. Y is our heart rate. How is the heart rate changing? Okay. We can see right here that the ideal heart rate drops 3 beats per minute. So that tells me that delta y is -3. Okay? Delta x is the years over 25. Okay? And this says for every year older than 25. So delta x is just going up 1. For every 1 year, the heart rate drops 3 beats per minute. So that tells me my slope is -3. Okay? Now I have to try to find b. Think about what my b is, or my y-intercept. To think about that, let's take a look at a graph real quick. Remember, my x is the years over 25. And that my y is the heart rate. Okay? So I'm thinking of, since x is all the years over 25, I'm thinking of this point right here where I'm starting as 25. Okay, that's kind of the 0, because I don't care about all the years under 25. I don't care about 24-year-olds, 23-year-olds. I care about the 26, 27, 28-year-olds. So at 25, where is the heart rate? The heart rate is at 117. So that tells me that my b is 117, and that my whole equation is y equals -3x plus 117. All I did was take the m that I found and the b that I found and plugged it in. Okay? Next part of this is to graph the equation. Y equals -3x plus 117. Okay? Now, when we do a graph, remember you don't have to draw 117 lines. We'll go up here and then just label it, telling us that that's 117. Okay, that's our y-intercept. Now our slope is -3/1, so I know it's going to drop 3. Whoops. Yeah, that was right. And over 1, giving me a line like that. Okay. As long as you label what each line is, you don't have to make every single line. Now, if we're only going to 8, yes, go ahead and make all the lines. Okay. But going to 117, just label what it's supposed to be. Okay. And the last part is to find the ideal maximum heart rate for a person exercising to burn fat who is 55 years old. So we have our equation, y equals -3x plus 117. Remember that y is looking for the ideal heart rate. Okay? And that x are the number of years over 25. Okay? Since I'm looking for the heart rate, find the ideal maximum heart rate, I don't know y. I can use 55 to figure out what x should be. X is going to be 55 minus 25 because it's the number of years. X is the number of years over 25. So when I plug this in, I'll get y equals -3 times 30 plus 117. -3 times 30 is -90 plus 117. So this tells me that the ideal heart rate for a 55-year-old in order to burn fat should be 27. Okay. So that's solving, or that's slope-intercept form. That's how to graph in slope-intercept form and how to use slope-intercept form in specific equations. All right. So let's go ahead and get started on the practice for this section. Make sure to ask plenty of questions during class, especially when you get to longer problems like this one. And I will see you later. Bye.